Hello, everybody, and welcome to this episode of the Ampere Developer Impact. A few weeks ago, I had the chance to talk to Craig Kirsteins, the Chief Product Officer of Crunchy Data, about how they're using Ampere servers as part of their productization process. It was a great conversation. I recommend you go watch the video. But in addition to that conversation, we talked about how Craig goes about analyzing performance issues in Postgres databases and some of the tools that you can use to identify the reasons behind performance issues that you're observing. It was a great conversation. It wasn't very platform specific, but I wanted to bring it to you as a separate tutorial. So without further ado, here is Craig explaining how to characterize and fix performance issues with Postgres databases. Enjoy. So when we were preparing this interview, Craig, one of the things that we talked about that kind of went down a little bit of a rabbit hole, I don't know if we're going to have time to include it in the interview here, but is kind of the process that you go through when you're looking to optimize a Postgres database. I asked you whether there were any specific optimizations on ARM64, and I thought your answer was really interesting. I was wondering if you could go into like roughly when somebody calls you in to say my database is too slow, what's the approach you take to help them fix it?
Yeah, if I can go ahead and share my screen here. There's a lot of, you know, a lot of people are like, all right, what are all the Postgres knobs I need to tune, right? Like, I think when you asked the question the first time, you're like, hey, like, is there some magical knob in Postgres, or how many config things do I need to change? And there's a great talk out there, I think, by a mutual friend of ours, Christoph Pettis, called PostgreSQL When It's Not Your Day Job. And it's kind of like, you're not a DBA, you're an app developer. Hey, there's a slide in there that's like, hey, these are the 10 configs you need to set for Postgres. Do that, and you kind of never have to worry about it. And if you're messing with Postgres config, go look at that talk. Once you've done that, you're good. Crunchy Bridge, our managed service, has all that configured for you. Like, you don't have to worry about it. If you're on a managed service provider, check and see if they've tuned it well. But most of the time, it's truly like on the application specific kind of side of things. And the first thing I do when I come into a database is I look for the cache hit ratio. And so I'm going to run a query here. This is going to give me the cache hit ratio. And what that means is how often is it reading data from memory versus disk? And I think when we were preparing for this, I asked you, like, all right, what's the performance difference in like going to disk versus in memory? Do you remember what you said there?
I think it's 2 orders of magnitude, right?
Yeah, generally 100x, right? And so Postgres, people talk about adding a caching layer, so forth, so on. Like, Postgres is keeping recently and frequently accessed data in memory already. And so here you can see on this is my demo database. It's not crazy exciting, but like, great, I'm in good shape. I've got 100% cache hit ratio on most of my very active tables, right? This is a good sign. You can take this query from here. You can look at the Crunchy Bridge. We've actually got a huge collection of Postgres tips within our website. You don't have to save this query. You can just Google and find it. Run it against your database. When this goes from like your most active tables from 100% to like 98, you're falling off a cliff, right? Like, you're going from that quick 1-2 millisecond to like 100 milliseconds. That's a huge impact on your database. Like, that's the number one place I'm looking at. Like, if I've got a good cache hit ratio, awesome. Beyond that, Postgres had something called PG stat statements. This is an extension that records every query that's run against your database and tracks how often it's run in aggregate, how many times, and the average time. My apologies, my demo database is not quite as exciting, but what you can do is go and query PG stat statements and give me something like, give me the most expensive queries against my database. Again, this is my demo database I've got running. So you can see I'm running this query here that generates a whole bunch of fake data for 30 seconds at a time. So it's running very, very long, generating a lot of data. If this were my application and that were my like top query, that would be a giant red flag to me that, hey, let me go and investigate and tune this query. So you can see on the average and the total time, here we're sorting by that average time. So if you see queries that are over 100 milliseconds, great, go tune those down to 1, 2, 3 milliseconds by adding indexes, right?
Okay.
Another thing that you can quickly check is your unused indexes. And so if you've added a bunch of indexes to speed things up, you can go and Now say, all right, are you using those, right? Have our query workload patterns changed? And can we go and drop unused indexes that are slowing down writes? And so this looks like a kind of gnarly query. It's not going to crash your database. It's super safe. It's looking at all these catalogs and stats tables from Postgres. This is a good sign. All of my indexes on my database are used, right? If I had
Okay.
any unused ones, they show up here and I can come in and drop those.
I
Now,
was going to ask you the cost of an unused index, because I would have thought it's pretty cheap other than disk space, but it slows down writes if you have
yep,
to.
because you're updating that index on every single write, right? So it's fine if you've got one unused index, but if you're a high write database and doing 100,000 inserts a second, there's a real cost to that. And
Okay.
if it grows over time that you've got 5 unused indexes, and why is my write now instead of 1 millisecond, 10 milliseconds? Well, okay, that's still fast, but that's an order of magnitude slowdown, right? Because it's updating 5 indexes at a time. And so over time, these things really do add up and build.
Yeah.
And I 3 queries there, I don't have to know anything about your application, your workload patterns to like, what were we, 5 minutes on a demo database, but this could be a real production database.
Okay.
And I'm probably going to bubble up some things. So basically, those kind of 5 queries, we've got a collection of Postgres tips on the Crunchy Data website that is literally a bunch of these queries. On production databases, I just come in here every 2, 3 months, every 6 months, check these, and you know, I don't have to go crazy deep. And you'd be shocked at how many easy wins you have by just like Postgres has this data. You just got to look at it,
Right.
and you can find things like N+1 queries, where you need to add indexes, where you need to drop indexes. Hey, you're low on cache hit, bump up to the next size of memory, and performance is going to go through the roof.
Okay.
It's kind of actually that simple. It's just most people don't look at it. So I highly encourage, if you're not familiar with these queries and haven't looked at them, take a look at them, run against your database. You probably have some aha moments pretty easily.
So in summary, for data that you're accessing frequently, you want to use enough memory that you can keep everything in cache,
As
maximize
much
the
as you
cache
can.
hit ratio. If you've got a read-heavy database, make sure you're using good indexes for the queries that are showing up as the slowest ones. And if you've got a write-heavy database, then make sure you're removing any unused indexes. Is that top
Pretty
level?
pretty much, right? And that PG stat cements is your friend on what are my queries doing, right? Like again, this isn't my best example here, but if I had a query showing up here, quick lookups on your database should be in that 1, 2 milliseconds if they're targeted lookups. So if you see something that's 10 milliseconds, 100
Okay.
milliseconds, dig in. How do you optimize that specific query? And then you know, and I look at it in orders of magnitude, right? You mentioned that, going to disk versus memory.
Yeah.
Hey, if this my average time is 100 milliseconds, and I know I can get that down to 1, that's 2 orders of magnitude. That's huge in performance I've given back to my system.
Brilliant. And how often do you see like just bad queries, like nested selects and things like that, where you're kind of doing ON squared type queries
It
for?
definitely happens. ORMs aren't the most elegant, but usually they've gotten better and better over the years. It happens. Sometimes you need to drop down to raw SQL in your application instead of an ORM generated query.
Okay.
It happens. Half the battle is knowing it's even happening, right? Most of the time you don't know it's happening because your ORM generated this gnarly thing. Oh, look, the ORM did something crazy. I know how to tune that. Hey, just seeing the performance of those queries from PG stat statements is going to tell you whether to go kind of dig in and tune that or not.
Okay. Well, Craig, thank you very much for joining me today. It's been a great pleasure talking to you, and I look forward to seeing you soon.
Yeah, thanks so
And
much for having me.
yeah, and to all our viewers, we look forward to seeing you on a future edition of the Ampere Developer Impact.